Only mode.
Good afternoon and welcome to CAD-1 Civil 3D H&H webinar presented by Brian Hailey, PE, and I'm Stan Henney, the Business Development Manager here at CAD-1. And we're looking forward to the new year. First off, let us wish you all a very happy new year and look forward to doing many more fun webinars with you folks. So we'll get started here, and let's see, Brian, there we go. It takes a minute to switch the screens. Most of you have seen this, but just for those of you who don't know, you need to set yourself up so you can either use mic and speakers or the telephone. You've probably already got that taken care of. You can raise your hand. You can minimize the console. That's the orange arrow now rather than a couple double white arrows. They just changed that. And most importantly, please feel free to ask questions using the question type-in box, and we will try and get to those questions as close to in context as we can. So with that, let's move on to the next slide. We have a few of the Autodesk promotions that go on for the next couple weeks, and this is our little commercial. We try not to make this too long for you here, but anyway, for the next couple weeks through the 18th, Autodesk is offering 2.9% financing with 90 days deferred payment and free Jolly Ranchers for everyone who attends and everything else. One of our preferred training partners, or excuse me, finance partners, is Partners Capital, because in addition to software financing, they also do they can also finance training and subscription renewals and so forth. So we'll use them whenever we can in your benefit. And Autodesk is making some fairly significant changes to their pricing structure after February 1st, so just in about 3 weeks. And this is fairly significant, especially if you have older software, older land desktop, or Civil 3D, AutoCAD that you're wanting to move to Civil 3D, something like that. Give us a call and take advantage of some of this before the pricing changes. It doesn't necessarily go up in every case, but it changes not to your benefit, unfortunately. So let us know. And yep, one more. There is the AutoCAD LT new seat promotion. So if you're needing a new seat of AutoCAD LT, you can get up to, let's see, $225 in rebate value there, $125 instant rebate on the purchase, and then if you buy the LT software with subscription, you can get another $100 mail-in rebate, and that's on Plain LT, Revit LT, Inventor LT Suite, etc. So I think that's all the promotions, and I'm going to turn this over to Mr. Brian Hailey, PE.
Thank you, Stan. So today, as Stan mentioned, we're going to be talking about H&H, hydrology and hydraulics. One of the things I did a lot of design of when I was back in doing design. So today we're going to be starting off, we're going to start the conversation revolving around hydraulics. All right, so what is the hydraulics that we're going to be talking about? We're going to be talking about some open channel flow. So I've got a ditch. How do I know how much water is flowing through the ditch? We're also going to get into creating stage and storage curves. So I've got a pond at this elevation. How much storage do I have in my pond? Another thing that I'm going to show is how to take a channel and export it out to HEC-RAS. Now, I'm not going to get into HEC-RAS and actually do a HEC-RAS analysis, but I'm going to show you how to get your data out of Civil 3D and into HEC-RAS so that you can start running these different types of analyses. Then we're going to get into the hydrology side of things. So when we get into the hydrology, I'm going to start talking about the basins. So how do we define the different drainage basins that we're going to be working with? We're going to use that to calculate the runoff, how much water actually from the rainfall actually ends up running off. And I'm going to route that through a pond. So we're going to create a pond, and then we're going to put some stormwater into a pond. And last, we're going to talk about some storm sewers. And basically this puts it all together. So we got a little bit of hydrology, a little bit of hydraulics going on in a storm sewer system. So we're going to do that here. Now, before I continue too much further, I got some questions I want to ask you guys. So, well, first of all, what version of Civil 3D are you using? So are you current? You're up on 2013. Maybe you're a little bit older and you're running something a little bit older. Maybe you've never used Civil 3D and you're not really sure what it is.
These are always interesting to see.
Yes, they are. All right, looks good. I'm going to go ahead and close this. And I'll go ahead and share the results here. And looks good. Looks like most people are up and running in 2013, about half. That's kind of what I expected. If you're not aware that the service pack for 2013 has been released, I know a lot of people wait for the service pack to come out before they move up to a newer version. I got a few people that are hanging on to that older version.
And that probably one person who has that 2010 or earlier, give us a call.
All right. What about the infrastructure design suite? Do you have the infrastructure design suite? Maybe you don't know what the design suite is, so maybe you don't have it. Maybe you have the standard version. Now, if you're running Civil 3D, you probably don't have the standard version. So standard version does not come with the premium. Yep. Most people that are on Civil 3D have the premium version. So, and then the Ultimate is the one that includes Navisworks and Revit Structure.
Right.
So, I'll go ahead and close that and share the results here.
Yeah, good.
So this is about what I expected.
Yeah,
I expected it a little bit higher, perhaps, but this is cool.
Well, just so you know, and again, it's not a sales pitch necessarily, but there really are some pretty good tools in that infrastructure suite, premium and ultimate. But premium is really enough for a lot of people. And we'll be running over the course of the next few months. We'll be running some suites webinars just to show you how to use some of the tools that are in those programs so you can kind of see whether it's right for you or not. I will tell you that the infrastructure modeler tool is a wonderful tool. If you don't buy it for anything else, that is a great tool.
Yeah, it's
and
really slick.
Mr. Hailey is one of the best at using it. So.
All right, so when it comes to Civil 3D, what's your skill level? Maybe you've never used it. This is really the first time you're getting into it. Maybe you've been using it for a little bit, but you're still pretty new at it. Yeah, that would be a beginner. Intermediate is, yeah, I'm fairly confident with it. I'm doing pretty good. Expert would be, I am the go-to guy at my office. All right. All right, we got some confident people here. I like that.
And if you move over, I can do this webinar. We're handing you the controls and going to lunch.
Yeah, we got somebody that did it at least. I don't know how many people, but I'm guessing I know his name, and his initials are probably BT. So let me go ahead and hide this. So it looks like most people are intermediate. What about your H&H knowledge? It's H&H, how would you, maybe you're fairly new at the whole hydrology and hydraulics things, not really sure what it is. Maybe you consider yourself to be an advanced. And
Kim, while everybody's filling out this question, Kim, we will be recording this webinar. We are recording it, and it will be posted on our YouTube channel in a I don't know how long it takes. It kind of varies, but in a couple days probably.
Yeah.
And you can access that by going to cad1.com/events/webinars, and you can link to the webinar and watch it anytime you want to. So sorry that we had to change things a little bit, but we will have that recorded in a few days.
Hey, and just so everybody else knows, Stan was just answering somebody's question that they typed into the question box, which is what you guys should do whenever you have questions. So
exactly.
All right, I'm going to go ahead and share the results here, and apparently somebody thinks they're better than Dr. Guo. That's impressive. So anybody that doesn't know Dr. Guo, he's the guy that developed the urban drainage storm manual and part with urban drainage. He's a professor at UCD and all sorts of fun stuff.
We can tell who the geek in this room is.
All right, looks good. So let me go ahead and continue on with the presentation here. So as I said, we're going to talk hydrology and hydraulics. Now, throughout this presentation, really there's 3 different pieces of software that I'm going to be showing off here today. All right, the first one is Civil 3D. So I'm going to be showing off Civil 3D, of course. The other thing is the HydroFlow Express. So this comes with Civil 3D. This was part of the acquisition that Autodesk had when they purchased the HydroFlow stuff.
Just real quick, because it's pretty funny. He says, Richard says, maybe Dr. Guo is listening.
Excellent. Yeah, so the HydroFlow Express is the HydroFlow stuff, the IntelliSolve, and I'm going to be showing off some of that stuff. And last but not least, I'm going to show off the Autodesk Storm and Sanitary Analysis. This was part of the Boss International acquisition, and I'll be showing off a little bit of that as well. So enough with this PowerPoint stuff. Let's go ahead and get into it.
And just so you know, if you are looking for the archives page, I did post that. You should be able to see that answer on the question box there now.
Right. Excellent. So actually, let me get back here to a little things. I don't want to miss any of the things. So the first thing I'm going to be talking about is open channel flow. So within Civil 3D, we have a lot of different tools for hydraulic analysis and hydrology analysis. If you're familiar with the StormCAD suite of or with the Hasted suite of programs, they have StormCAD, PondPack, FlowMaster, CulvertMaster. We pretty much have the same functionality from those programs here in Civil 3D. So underneath my Analyze tab, let me move that out of the way. If you expand out the Design panel, what you'll see is I have these 3 applications here. I have Storm Sewers, Hydrographs, and Express. The one I'm going to be showing off today is Express. Now, these, as I said before, these 3 programs pretty much cover the functionality of those 4 programs from Hasted. Storm Sewers will cover StormCAD. Hydrographs covers the functionality of PondPack. And Express covers FlowMaster as well as CulvertMaster. So I'm going to go do an open channel analysis. I want to know what the depth of my flow is in this specific channel. So I'm going to launch Express. So it actually launches as an external program. And then I just come over here and I choose what it is I want to calculate. If you want to calculate a culvert, there's your culvert tab right there. You want to calculate an inlet or perhaps a weir. Right? In this case, I'm going to do a channel. So what kind of channel do I want? Well, I'm going to do a trapezoid. This is perhaps a drainage swale. And I just go fill in the information that I have. So my section type is trapezoidal, my bottom width. Right? How wide is the bottom of my ditch? Well, I'm going to make it a 2 foot wide. What are my side slopes? Right? So the side slopes. So I'm going to set these at 1 to 1.
And Chris asks, is there an orifice calculator?
Is there an orifice calculator? Let's see. I know sometimes things get a little, they give me, oops, I lost it. I don't remember, honestly.
We'll check into it.
Yeah, I believe it's under the, no, it's not under wares. Where is it? I thought there was one. No. Unfortunately, I don't think there is one, at least not here in this particular tool. So my total depth, what is my allowable total depth for this particular channel? So I'm going to say it's 3 feet deep. My invert elevation, it really doesn't matter what you put in here for an invert elevation. You just have to put something in. Not exactly sure, but it doesn't like 0. My slope. Well, how steep is the channel? So this is in percent, so I'm going to say it's at 0.4%. And then my end value, it's a graph, so I'm going to say 0.02. And then, how do you want to calculate this? So I want to calculate the Q value versus the depth within the channel. And I want to do it in 10 increments. So I then run that. And now down over here, it shows me basically the rating curve. So at a depth of 0.3 feet, I have 1.26 CFS. And as I select these different settings, you'll notice that graph up top changes, showing me how full the channel is going to be. Completely full, this has a capacity of 89.5 CFS. So this is an example of how you can use, do those quick calculations here.
And Harold has a question. How come there is no longer the interactive table of N values or the clickable selection of elevation/grade, etc., as there was under land projects?
Assuming you're referring under land projects, I'm not sure what you're referring to, perhaps under land desktop. I was land desktop, this is Civil 3D. Things are different, perhaps?
Yep, that's what he was referring to.
Okay. Yeah, it's just a different program. So this is what we're using now. Honestly, I never trusted the H&H stuff that came out of land desktop. I saw too many errors. But, that's my personal opinion. So I'm going to go ahead and move on. If anybody has any questions on the HydroFlow Express, feel free to type them in, and we'll get to those. Let's see, what else do I want to talk about here? Pond stage storage. So create a stage storage curve. Calculate that table that shows you at this elevation, I have this much volume. So let me go ahead and open up a drawing here real quick. So in here I have a swale coming down through my project. All right, it's flowing down this way, and then I decided, hey, I'm going to put in a berm across this draw, and I'm going to use this for my detention. And I want to know how much volume I'm going to have here. So I'm going to go run my stage storage calculation. So this is, again, going to be found underneath the Analyze tab. Analyze tab, that's where I go to compute things. And under Design, the same place where I went to launch the Express, I'm going to run the stage storage curve tool. Just walk your way through, give the report a title. Let's see. Every once in a while you get the little things that stay up. So I'm going to give this report a title. I'm going to call this one Pond Date. Project name will be Brianville. And basin description, I don't know. Description. What method do you want to use to calculate the volumes? Do you want to use the average end area? Do you want to use the conic approximation? This is also known as prismoidal. Or do you want to use both options? In this case, I'm going to go ahead and do both just so we can see how they're different. And then, well, do you have something in your drawing that you can use to define your basin? If you do, I'm going to use the define basin from entity. If you don't, you can simply use the manual control and then simply define the basin. It'll ask you, okay, at this elevation, what's the area? At this elevation, what's the area? At this elevation, what's the area, etc. And you just go through and you fill in the table. I don't have that in this case. So I'm going to use the define basin from entity. And then I come over here and define the basin. So it brings up my Define basin from entities, dialog box. My basin name, you can give it a name if you want, so I'll just call this basin name. Do you want to define the basin from surface contours? Ooh, that sounds really tempting, doesn't it? Yeah, typically this is not one you're going to use. The reason is because this will grab every contour from your surface and use it for the state storage analysis. I don't want to use every contour. I just want to use just these few contours. So I'm going to choose instead define basin from polylines. And I'm going to extract the objects from the surface. So if you're familiar with the object extraction routine within Civil 3D, that's basically what this is going to do. It's going to go extract the contours out, and then I'm going to go select them and say these are the polylines I want to use in my curve. So extract objects from the surface. Simply ask me which surface do you want to use. So I grab my surface. So it went through and it copied all those contours and made them into polylines basically. I'm going to change those polylines that I select to a different layer. So it's going to put them on the HH-basin name layer. I can change this if I want. And then I define my pond. And I simply just go through and I select those polylines that I extracted out from the surface. So those are the contours that I want to use for my basin. And it fills in the table for me. A couple of different things I can do with this table. I can create a report from the table. So I choose Create Report. It's basically going to save it as a TXT file. So I'll call this Pond Stage Storage. And it creates a report for me. I can then take this text file and import it into Excel and do anything that I want with it. Another thing I can do is I can insert this into my drawing as a table. So I'll choose Insert, and I'll just pick a point in my drawing, and there's my table. Now one thing to note, this is a static table. This is, in fact, just an AutoCAD table. So if the surface changes, if those polylines changes, you'll need to run through the process again.
And you might want to watch our linking data to Civil 3D webinar from about a month ago if you want to know more about that.
Yep. All right, so there's my table, and as you can see, it gives me the totals for both the conic approximation as well as the average end area.
And Jake asks, those were polylines and not surface topo lines, right?
So what this did, Jake, is it took those contours from the surface and it created polylines from them. And then it ran the routine on those polylines. So it's a little bit of both. Right. And like I said, if you change something, you'll have to go through and run the routine again.
And Jake says, awesome.
Now one thing this does, if you notice, I now have these white polylines in here. So when I ran the routine, I told it, hey, I want you to put these objects on a different layer. There was also an option to erase all the unselected polylines. So this extracted all of the objects. So you'll notice I now have polylines that represent all of my contours throughout the entire surface. There is an option to say delete these, but for whatever reason it doesn't work. That's why I didn't bother to toggle it on. But it's not that big of a deal. You grab one major, one minor contour polyline here. Because I put these on a different layer, I can just simply right-click, select Similar, grabs them all, except for those ones I converted, and then I just erase it. So it's not the end of the world. It's just something I'd like people to be aware of. And so now you can see there are no polylines there any longer. All right. So that was the stage storage tool. Let's talk about exporting out to HECRAS now. So quick show of hands up there on your little go-to meeting. How many people here have used HECRAS? Just one kind of curious.
Finally, you found something to use the hand button for.
All right, excellent. It looks to me about half.
About half, yeah.
Yeah. Excellent. So Oops. So HECRAS, let me go ahead and close out of this drawing here. Actually, let me just go open a different drawing. So I've got basically the same scenario going on here. Same little area. I've got this draw running through my project. And instead of putting in a pond here, I just want to do a HECRAS analysis through here. I have an alignment that's running along the flow line. Now this alignment currently is the station starting down at the bottom and working its way up. So station 0 is down here. Station 100 is towards the upstream end. I also have a series of polylines in here. So if you notice these white polylines, these are the sections that I want to use in HECRAS. So I need to be able to get this information out. And the other thing that I have is I have a couple of polylines here, and these represent the left and the right overbanks. So as I'm creating the sections within HECRAS, I want these to be used for the overbanks. So under the Output tab, I'm trying to create something outside of Civil 3D. I'm going to export to HECRAS. Well, actually, sorry, I totally skipped an entire section. I got to create the sections first. Sorry, I got a little distracted there for a second.
Hailey likes to mess with your head.
First thing I need to do is create the sections. So I have the alignments, I have the polylines, I need to create the sections. So these in Civil 3D are referred to as sample lines. Before you can create a sample line, you have to have an alignment. So I'm going to go create my sample lines. I'm going to select the alignment that I want to use to create my sample lines. And then what data do you want to sample? So you're going to sample that surface that you want to get your cross-sections out of. Now in my case, I only have the one surface, so I'm just going to leave everything as it was. But if I had a couple of different design surfaces and existing ground surfaces, I'd simply toggle on the one surface that I want to use here. So now I'm creating my cross-sections. Well, it's going to ask me, where do you want the section to be? Well, I don't want to pick a station. I want to use these polylines. So I'm going to use this little pull-down, and I'm going to choose Select Existing Polylines. I want to use those polylines for my sections. All right, I'll just go grab those polylines. I'm done grabbing them, so it made them into sections for me, into sample lines rather. And I'm done. So it created the cross-section for me within Civil 3D. If I want to, I can go create a section view, and I'll just create a single section view here, just to kind of see what that section looks like. So this is what my section looks like at one of those stations. Now that I've got the section created within Civil 3D, I now use the tool to create a file that we can then import into HECRAS. And that's under the Output tab, Export to HECRAS. All right, which surface do I want to export? Which site? This is just so you can select the correct alignment. And then which alignment do you want to use? For that alignment, which sample line group do you want to use? In this case, I only have one alignment, I only have one surface, I only have one sample line group, so it's really easy to do. I'll give this a name. So the river is going to be the Little Mississippi. I don't know, I'm just making something up here.
Yes, you are.
All right. And then if I want to, I've got those polylines in there, I can use those river overbanks. So I'll just go ahead and toggle that on. So which object do I want to use for the left side? So I choose left, and then I pick the polyline that's on the left side. Do the same thing for the right. And I'll select the object that's on the right side. Now, in previous versions, you had to have these as alignments. In this version, it's actually going to make them into alignments for you. I then export this. Don't just hit OK. If you hit OK, it closes the dialog box. It doesn't actually do anything. So I have to hit export. It's going to ask, where do you want to save it? So I'll call this one H and H demo. It's going to save it as a GEO file. Save that, and now I have the GEO file. And now I can hit OK. And as you can see, it took those polylines and made them into alignments. If you don't like them as alignments, you can just always undo that and put them back to being polylines. Now let me go ahead and run HECRAS. So now here in HECRAS, I'm going to go create a new project. I'll give it a name. I'll call it Demo for the lack of originality on my part. And I'm going to go to the geometry editor. So I'm going to edit, enter geometric data here. And I want to import those sections into HECRAS. So I'm going to come down here under the File option, Import Geometry Data, and I'm going to use the GIS format. So that GEO file is considered a GIS format within HECRAS. And I simply browse to that data. So I'm going to have to go browse to it here. Oops. Got to be here somewhere. So here's the Little Mississippi. Walk your way through the process, right? It's imperial data. Is it customary unit, U.S. units? Is it imperial or metric units? All right. I got some options in here. Shows me everything that's going to import. I finished the imported data, and there is my river showing here. Now, something's wrong. It's going the wrong direction. Typically, when we're doing these sorts of things, we start down at the bottom end, and we station upstream. That's the direction the alignment's going. But that's not the direction I want the flow to go. I want the flow to go the other direction. So here under the Geometric Data Editor, I'm going to choose GIS Tools, and I had this issue earlier. Should be able to do the reach invert table. So let me try saving this real quick. There it is. I don't know why it just needed a little kick in the pants. I'm going to go to the Reach Invert Lines table, and I'm going to flip the coordinate order. Yes, I want to do that. And now you can see the river is going, or the stream, or the reach, or the whatever it is going the direction that I intended it to go. So this is how we can take that Civil 3D stuff and bring it into HECRAS. All right, so let's talk basins now. So we're done with hydraulics for now. We're going to move on to some of the hydrology stuff. I want to go in and I want to calculate a drainage basin. So I'm done with HECRAS. I'll go ahead and close out of HECRAS. And I'll go open up another drawing here. So here I have a subdivision. I've been working in a subdivision. I've got all the grading done for the subdivision. I'm going to pretend it's done. And this isn't really what it's going to look like, but I'm going to pretend this is what I want it to be. And I'm going to come in here and I want to start defining drainage basins to these inlets. I'm going to use these two inlets as an example. So what area is contributory to this inlet and what area is contributory to this inlet? So under my Analyze tab, again, this is where I go to compute things, catchments. I'm going to create a catchment from surface. Now, if you don't have a very well-defined surface, this tool doesn't work very well. But if you've gone through and modeled your surface fairly accurately, this is a really nice tool. So I'm going to create a catchment from a surface, specify the discharge point. Well, I'm going to choose the middle of this inlet here. All right, what are we going to name this? So I'm going to name this one Catchment 1. That's fine. You can go through and rename them. It's going to put them in a catchment group. Which surface do you want to use? So I'm going to use this composite surface. The reference pipe network structure. So where does it drain to? Does it drain to an inlet? If it does, well, I can go ahead and select that inlet in the drawing. So I want that catchment to connect to this inlet. All right, so in this case, it's inlet F1. Right, I can change the layer it goes onto, the styles, select OK, and it creates the catchment for me. Let me go ahead and repeat the process here for this one, and then I'll show you what it did. So I want that one to drain to this inlet. And so I now have two catchments. So this is the area that's going to drain to this inlet. Why isn't this area in here contributory to it? Well, it's going to flow down here, it's going to hit this street, and it's going to flow down to this low point down here. So it's not contributory to these inlets. Under my prospector, you'll see I have catchments. So I have catchment 5 and catchment 6. And they have a flow path. So it's kind of hard to see, but right there along the flow line of my curving gutter, you'll see the flow path. And again, that's following along the surface. If you edit the flow path segments, the only way that I know to get to this is to actually do it through the prospector. Choose Edit Flow Path Segments. You can actually come in here and start doing things like putting in the different flow regions. So I can add in additional regions. So I hit the little plus there, and let me go ahead and shrink this up a little bit. So I got one region that, so as you can see, this is where the flow is. Now I want to go to about there. And then that's my shallow concentrated flow. If I wanted to, I could do another flow path. Maybe I'm going from overland flow to shallow concentrated flow to channelized flow. I can start putting those different things in here. All right. Based off the SCS, I've got 3 different types of flows. So if you're doing a time of concentration using the SCS method, here's where you can set those different regions for this. And I just continue to do all the rest of everything in here, and I'm good to go. So I've defined my basins. Well, now I need to know how much water is coming off this stuff. So I'm going to take all this information into a program called Autodesk Storm and Sanitary Analysis. Now let me go ahead and save this drawing here real quick. So I'm going to take this into SSA, Storm and Sanitary Analysis. I've got a tool button right up here that allows me to edit this in Storm and Sanitary Analysis. When you install Civil 3D, it also comes in through your Windows Start button, so you can also access it through there. But I'm just going to choose Edit in Storm and Sanitary Analysis. The reason I like to do this is because it's actually going to take all of the pipe networks that I have in this drawing and bring them into Storm and Sanitary Analysis as well. So I'm not interested in the sanitary sewer right now. I'll uncheck that. Select OK. It's going to open up SSA, and it's then going to take my pipe networks from this drawing and bring them into SSA. I'm going to go create a new project here. It's also going to take those basins and bring them into SSA, and it's going to attach the basins to the appropriate inlets. It's also going to take the drawing I was in and bring it in as a background image. Do you want to save the log file? It's just showing me what it is I did. So I'm not really interested in the log file right now. In fact, I'll go ahead and close out the log file. And there's my project. So let me zoom in here a bit. As you can see, my inlets came in as inlets. My manholes came in as manholes. And those 2 inlets that I calculated the subbasins for, they came in with the associated subbasins. And if I double-click on the subbasin here, you can see it has time of concentration already calculated. It has the area. And if I want to, I can come in here and start modifying some of this. All of that fun stuff.
Jake asks, can I create a catchment without a pipe network?
That's a good question. Can you create a catchment without a pipe network? In Civil 3D, yes, you can. But when you bring it into Storm and Sanitary Analysis, it needs to be associated with a pipe in order for it to transfer. At least I'm pretty sure it does. Let me try that. You got me thinking here. Let's find out. I've always been told, don't try anything you haven't tried. Don't show anybody anything. Nah, okay, whatever. So let's see. I want to do this inlet here.
You got him thinking, and that's a rare thing to do.
So I can just draw a polyline. Say, hey, I want this to represent this area here. All right. I'm just being really quick and dirty right now. And then I'm going to draw another polyline that represents the flow path. So this is where the water is going to flow. That's all I did. Closed polyline for the area, a single polyline represent the flow path. Under my catchments, I can then create a catchment from objects. So I know you can create catchments in Civil 3D without a pipe network. Now it's going to ask me to select the polyline for the catchment boundary. And then select a polyline on the uphill end to use as a flow path. And now it's going to allow me to create my catchment. If this is referencing a pipe network, I can simply select that there. In this case, I'm not going to do that just to see what it does. Select OK. And now I have my catchment. So let's see what happens when I take this into SSA now. If I remember correctly, this one will not come through, but we'll give it a try. So I'm going to do exactly the same thing I did before. All right, I'm going to create a new project. And yep, these two basins did come in, but there is no basin down in this area. And if I go double click on one of these sub-basins, you can see there's only 2 sub-basins down here. So in order for the sub-basin to go from Civil 3D into SSA, it has to be associated with a pipe structure of some sort. You can always associate it with a manhole or something like that, and then once you get into SSA, you can always tell it to go someplace else.
So that's kind of what Brian had a couple questions here. I'll kind of do the in reverse order here. Can you just add a fake inlet?
Absolutely, and that's kind of what I was saying to
that's
do.
Kind of what I
have it attached to something,
yep.
And then once you're here in SSA, I can simply grab this and tell it to connect to something else.
And then Brian's other question was, what methods are available for peak runoff?
For peak runoff, ooh, that's a good question. I'll get to that one in just a moment. All right. So here we are in SSA, and I want to start doing some analysis. Now, just to make life a little bit easier for me, I'm going to get rid of some of these elements. I had more things on this storm sewer than I really need or than I want to deal with in this particular example. So I'm just going to come through here, and I'm going to get rid of some of these inlets. Now, each inlet also has an outfall. If you'll notice these red X's up here, right, that's for the overflow of the inlet. So if the inlet's on grade, where's the water going to go that bypasses it? So I'm going to go ahead and get rid of those as well. And again, the only reason I'm doing this is just to make so I don't have to input as much data to get some results out of here. And I'll do the same thing down here. All right. So again, now this particular has 2 inlets and a long pipe coming to an outfall. And really that's all that's in this one. So let's go take a look at before I get going in here, I really need to set the project up. So I'm going to come over here to the project options. Double click on my project options, and this is where I go through and I set everything. So this will answer your question here, Brian. So my unit system, I'm US units, my flow units, CFS, my hydrology methods. What method do I want to use to calculate my peak runoff? So I got all these different methods. Really, of these, the only one I've ever really used is the rational method. So Link routing method. If you're going to run into a situation where you might have backflow, flow looping in on itself, something like that, you need to make sure this is set to hydrodynamic. Kinematic wave will only go, is a linear approach. I don't have any of that, so I'm going to leave it set to kinematic wave. And I can change my labels, my prototypes. So when I create a pipe, you know, what's it going to be? It's going to be a circular pipe. So those are the defaults, basically. I also have my analysis options. So just below the project options, I have my analysis options. So when I'm running this analysis, well, what do you want it to use? So I want to start my analysis at a specific time, and I want to end it at another time. So in this case, I'm going to do an analysis of 1 day. I'm going to have a storm, and it's going to start at the beginning of the storm, and it's going to continue on analyzing for a day in this example. Let's see, the storm selection. So which storm do you want to use? So I'm going to come in here and I'm going to use the 100-year storm. Ooh, the 100-year storm. What is the 100-year storm? Well, if I come over here to my IDF curves, intensity, duration, frequency, I can create the curve to be whatever I want.
And while you're thinking about this, because this question may just tie right in there, Brian also asks, is there urban drainage time of concentration?
Urban drainage time of concentration. Well, let's take a look at the different types of time and concentration we can do. So, I'm sorry, not under analysis, project options. So my time of concentration method, these are the different time of concentration methods that we have. So if you don't have one in here that will work for whatever jurisdiction you're in, you can always do a user-defined time of concentration. So you use the urban drainage methodology to calculate your time of concentration, and then you can manually input it in here. But these are the only options that we have currently. All right. Now, this particular pipe network was, kind of originally designed to have a whole bunch of extra inlets coming in here. And so what I'm going to do, just to make things a little bit more interesting, I'm going to bump up the areas here. So instead of having an area of 1 acre, I'm going to make this one 30 acres. And this other one, I'm going to make it 15 acres, just so we can get some actual water flowing through here. Once I've got my system set up, well, I can run the analysis. Yeah, it's the little icon of the guy running. Get it? All right, so I run the analysis.
Those Autodesk people.
And as you can see, I've got some situations here. I've got some issues here. I've got this big blue dot here. I've got a big blue dot with a red line up here. What is going on here? I got another big blue dot down here in this road. Well, let's go find out. I'm going to go create a profile and see what's going on. So I'm going to right-click on the node that I want to start my profile at, and I'm going to start a profile plot from this location.
By the way, if you're ever driving through your neighborhood and you notice a big blue dot on the street.
Where do I want the profile to end? Well, I want it to go all the way up here to the end. And if you notice, it selects everything between those two nodes that I selected. I then show the plot, and it shows you what's going on here. So maybe I picked too big of values for this example. And as you can see, I've got some things going on. Well, what exactly is going on here as far as the time goes? Well, let's run the animation. So under the output menu, I can create an output animation. I got my little player controls over here, just like you have like in your VCR, right? Ooh, VCR, what's that? I'll just go ahead and play this, and you can watch the storm go through the system. Okay, so at the beginning of the storm, it's raining just a little bit, and then at one point, the peak hits, and you got the different runoffs coming through here. And so you can see what's kind of going here. And as in this case, my system is definitely undersized for those basins that I put in. So I need to come through here and make some changes. And then the storm ends out, the rest of the water comes on down through, and there we go.
Actually, that's pretty cool.
Isn't that cool? Yeah. And you can take this sort of thing, you can record this. It'll create a little video file for you. You can take this to the planning commission, to your neighborhood meeting, and show them, hey, this is what's going to happen during this particular storm. So during the 100-year storm, this one's over capacity or under capacity. But what if I do just a 2-year storm? So I'll go back to my analysis options, and I'll change my storm to a 2-year storm, maybe a 10-year storm. Run the analysis again. And you can see one of the blue dots went away. Go ahead and create my plot again. So I start my profile plot down here at the end. Come all the way up to the top. And I'll select that very last one. Oops, I didn't need to right click. Just left click on it. It selects everything between, and I'll show the plot. So I still got some issues here with this project, but not as many as I had during the 100-year storm. So I know I need to come through here, change some inverts, perhaps, make some change the sizes of my pipes, those types of things. Oh, by the way, if you're done with the profile and you want to get out of this, do not hit this button up here. That will close the program for you. I've done that so many times. Now I'm just going to close the profile plot. So I need to put a pond down here. Right? I already I put in that I put this berm across this drainage way here, and I want this to start ponding up back in this area. So I'm going to simply put in a storage unit. I want to put in a pond. And I'm just going to have it display right there. So this pipe is going to discharge directly into the pond. Well, I want this pipe to be analyzed, so I could put the pond at the end there, but basically what I'm going to do is I'm going to take this outlet and I'm going to convert it to something else. I don't want it to be an outlet anymore. I'm going to convert it to a junction. And bear with me for a minute here. So it's now a junction, and then I'm going to connect this junction with the pond. Now the pond is huge. It's not a pinpoint location. So what I'm going to do is I'm going to use a conveyance element, and I'm going to connect the end of this pipe with my pond. Now this pipe really should have no hydraulic function whatsoever. It's just a connector. It's just a mathematical connector here. So I double click on it, and I'm going to convert this to a direct connection. I don't want it to be a pipe or an open channel or anything like that. I want it to be a direct connection. And so there's going to be no hydraulic routing or anything through this. Now my pond itself, well, I simply come through here and I set up my pond. What type of pond is it? How do I want to define the pond? Is it functional? So I can put in a mathematical expression to define this. Well, I don't have that. I have a storage curve. Remember back in Civil 3D I calculated that storage curve, so that's what I'm going to use here. I don't have a curve listed here yet, so I need to go create a curve here within SSA. And I'm going to add a curve. I'm going to call this one pond. And this is going to be depth versus area. So back in Civil 3D, I've calculated this table. I'm simply going to take these values and put them into that table. Now, just to make my life a little bit easier, I'm going to take this and just drag it off onto my second monitor. I know you guys can't see it over there, but I can. And now back over here in SSA, I'm simply going to come in here, type in the depth. So at an elevation depth of 0, I have an area of 0. Now this is a really big pond. I have just a little bit of flow, so I'm going to kind of truncate things a little bit. So at 2 feet deep, it's going to have an area of 36 square feet. So that stage storage calculation that we did actually ended up with 3,600 square feet. Just to make things more interesting here, I'm just going to truncate them by, or divide them by all by 100. So at 4 feet, I have a depth or area of 140. 6 feet, and you just go through here and type this in. I have 304 at 8 feet. I have 537, and at 10 feet, I have 830. And as you can see, my storage table over here on the right, this is that stage storage curve that we calculated back in Civil 3D. And now I have my pond created. This is the depth of the pond. My invert elevation, so based off of the contours that I have, my low elevation is going to be 5146. My max elevation, well, it's going to be, I don't know, 10 feet. I'm sorry, it's not depth, it's elevation, so it's going to be 5156. My initial water surface elevation, set at 5146 to be the same. And I'll go ahead and close that. So I've now created the pond. Great, now the pond's going to fill up. Where's the water going to go? Well, I'm going to have two different outlets on this. I'm going to have a pipe coming out of it, and I'm also going to have an overflow weir. You can continue to add additional pieces. I have an orifice for my water quality. I have an orifice for my 10-year. I have an orifice for my 100-year, and then I have an overflow for a weir, a broad-crested weir for anything beyond that. So I'm going to come in here. I'm going to put an outlet, an outfall, rather, down here. And now I'm going to connect the pond to the outfall using a weir, an orifice, rather. So this is going to be my control orifice. And I'm going to go from this pond. Now, this is just a graphical thing. I'm going to come up here so I can differentiate it from any other pieces that I'm going to have coming out of here. I double-click on that to go in here and change the values of it. So what size orifice is this? Well, I'm going to start off with a 4-inch orifice. And it's got a crest elevation of 5146. So at the very bottom of the pond is where it's going to start coming out. I'm also going to put in an overflow weir. So I add in a weir. Do the same thing. Go from my pond. And again, I'm just going to put this jog in here so they don't overlap each other. And I put in the values for the weir. My crest elevation. So it's going to crest at 5156. The length, it's going to be, I don't know, 6 feet wide. It's going to be 2 feet deep. And it's going to have 1-to-1 side slopes. You just fill in the information that you have. I then run the analysis one final time. And if I go into my pond now, it's going to show me, under the report, all sorts of information. Actually, it shows it to me down here as well. So there's my maximum water elevation, 5155.84. The peak flow in, 13.85. The maximum depth, all sorts of fun things here. All right, that report opens up in Excel, so I've got this. I can do whatever I need to with this. Print it out, put it in a report. And I can do the same thing for my weir. All right, so my peak flow for my weir is 0 CFS. I never actually reached the weir. Peak flow for the orifice, 1.34 CFS. So what happens if I make this orifice diameter a little bit smaller? I'll make this a 2-inch. Rerun the analysis. And now my weir, you see I messed something up. I can tell that because of the little blue dot there. Maybe I put my weir elevations above the top of the pond or something along those lines. But I can simply change that value and everything changes. So great, I've gone through here, I've run this analysis. I can then take this and I can export it as a hydroflow storm source file. Now, because I came in here and I added in some non-storm sewer stuff, this isn't really going to work all that well, but if I was just doing storm sewer in here, I can export this as a storm sewers file. It's going to save it as an STM file. And then back in Civil 3D, and I'm just going to kind of talk about this. I'm not actually going to do it in this case. Back in Civil 3D, under the Insert tab, I can import a storm sewers file. And when I import this in, it's going to detect, hey, you already have, oops, I'm in the wrong file. You already have a pipe network in here. What do you want to do? Do you want to create a new pipe network, or do you want to update this one? And if I choose to update it, when I bring it in, it's actually going to bring in the hydraulic grade line, energy grade line information as well, which in this case I don't have. And then I can display that in a profile if I want to. So,
we got a question from Brian here.
okay.
Goes back about 10 minutes. Can the HGL and EGL be added to each pipe so it can be shown in the profile within Civil 3D?
Yeah, and actually I just answered that one.
I was
so
going to
here's,
say,
yeah.
I thought so. But
Yep, so here's the hydraulic grade lines. And then when you're working, if you want to see those hydraulic grade lines within the profile, that's property of the style of the pipe. So I'm going to edit the pipe style here. Under profile, or I'm sorry, under display, I change my view direction to profile. I can tell it, do you want to display the hydraulic grade line and the energy grade line?
okay, and Chad asks, can you have the HGL for multiple storms in Civil 3D?
Multiple storms, hydraulic grade lines, energy grade lines, no, you cannot. A pipe can only have one energy grade line and one hydraulic grade line within Civil 3D. So unfortunately, you can't show the 100-year and the 10-year, or the 100-year and the 2-year, or anything like that. Not with a single pipe within Civil 3D.
Be nice if you could.
That would be. Perhaps in 2014. Or whatever they're going to call the next
Don't
version.
talk about futures.
So I said perhaps. I honestly don't know.
Now we have to do that safe port thing, that safe harbor thing. Things we say here may not be really true.
Yeah, that don't.
Maybe
Yeah,
a bunch of baloney.
I'm making that up. If you could.
So, what's next?
That's it. That's
All
all we
right.
got.
Well, we're
So does anybody have any questions?
just about on time here.
Yeah. So I'm done with the demonstration. I'd like to open it up for any questions you guys may have. While you guys are frantically typing out your questions, I just want to bring this up. So you know, we do have an online presence. CAD-1 is on Facebook. CAD-1 also has a Twitter account, so if you're into those types of things. I also have my own Twitter account, so C3D Plus, that is me, and I also have a link to my blog up here.
And I do want to say, once again, for those of you who may not have heard, we're very pleased and proud of Mr. Hailey. He was awarded at the recent Autodesk University by Carl Bass himself, the CEO, the status of technical elite. So once again, congratulations, Brian. That really is quite an honor. We don't want to make light of it because it really is pretty cool. Robert's got a question here as we close up. Is there a way for SSA to input the storage object data directly from Civil 3D rather than re-entering it?
That's a good question. Can you bring that stage storage table that we created in Civil 3D directly into SSA? Currently, there's not that I'm aware of. So it's right now the workflow is to have it up on both screens and type back and forth between each other. So.
All right, then there's no further questions, so we'll wrap it up about 4 minutes over time, but it was well worth it. Thanks very much, Brian,
Yep,
and
thanks, Dan.
we'll see you folks in the next webinar. Thanks a lot.